We are studying the applications of partial differential equation. In the applications of partial differential equation, very important problem is the string problem, one-dimensional wave equation problem. What is the equation of one-dimensional wave equation? The wave equation, what is the equation? Wave equations. And the wave equation is dou square y by dou t square is equal to alpha square dou square y by dou x square. What is alpha square? T divided by m. What is alpha square in the one-dimensional wave equation? T divided by m. T for tension divided by m for mass per unit length of the string. Okay. So this is a wave equation. Dou square y by dou t square is equal to alpha square dou square y by dou x square. This is one-dimensional wave equation. So let us see one problem. So boundary conditions are, how many boundary conditions are required to solve one-dimensional wave equation? 4 boundary conditions are required. How many boundary conditions are required to solve one-dimensional heat equation? Only 3 conditions. How many boundary conditions are required to solve two-dimensional heat equation? 4 equations. 4 boundary conditions. So only one-dimensional heat equation, we need 3 boundary conditions. Okay. So this is very important. So let us see one problem. A string is stretched and fastened to 2 points, x is equal to 0 and x is equal to L apart. The motion is started by displacing the string into the form y is equal to k into Lx minus x square, from which it is released at a time t is equal to 0. Find the displacement of any point on the string, distance of x from one end at a time t. So one end is 0, another end is L. So the limit is 0 to L. First we have to write the given equation is wave equation. One-dimensional wave equation is dou square y by dou t square is equal to alpha square into dou square y by dou x square. The boundary and the initial conditions are, first condition is one end is 0x, another end is x equal to L. So therefore y of x comma t in general, instead of x you have to apply 0, instead of x you have to apply L. So first condition is y of 0 comma t is equal to 0. Second condition is y of L comma t is equal to 0. Here velocity is not given. In this problem, velocity is not given. That's why we are taking dou y by dou t. That is for velocity. Velocity is equal to dou y by dou t. Okay, velocity is equal to dou y by dou t. The velocity is not given. So dou y by dou t is equal to 0. But y that is given in the problem, y of x comma 0 is equal to k into Lx minus x square. That is given in the problem. The limit is 0 to L. The most suitable solution is, or else the suitable solution is y of x comma t is equal to c1 cos px plus c2 sin px into c3 cos pat plus c4 sin pat. Take this equation number 1. So condition number 1, substitute or use condition number 1 in equation number 1. What is the condition number 1? For x you have to apply 0. So where is x in this suitable solution? You have to apply 0. So y of, for x is 0, y of 0 comma t is equal to c1 cos 0 plus c2 sin 0 into c3 cos pat plus C4 sin PAT is equal to 0. So y of 0 comma t, what is cos 0? Cos 0 is equal to 1. Sin 0 is equal to 0. Cos PAT, sin PAT, as it is you have to write. So y of 0 comma t is equal to C1 into C3 cos PAT plus C4 sin PAT is equal to 0. So C1 is equal to 0. C3 cos PAT plus C4 sin PAT is not is equal to 0. Is not is equal to 0. We have got C1 is equal to 0. So substitute C1 is equal to 0 in equation number 1. Equation number 1 is here. So y of x comma t is equal to C1 cos px. C1 is 0. So that term will vanish. So remaining terms will be in the equation number 2. C2 sin px into C3 cos pat plus C4 sin pat. Take this equation number 2. Next, use condition number 2 in equation number 2. What is condition number 2? Y of L comma t. Y of L comma t. So y of L comma t here is y of L comma t, which is equal to C2 sin PL, C3 cos PAT plus C4 sin PAT is equal to 0. Here, if you are taking C2 is equal to 0, if we are taking C2 is equal to 0, substitute C2 is equal to 0 in equation number 2. And now, suppose if I am taking C2 is equal to 0, substitute in equation number 2. What will be in the right hand side? Tell me. Santosh. C2 க்கு பதிலா 0 எடுத்து இந்த இரண்டாவது ஈக்குவேஷன்ல சப்ஸ்டிட்யூட் பண்ணோம்னா என்ன வரும்? ரைட் ஹேண்ட் சைடு. லெஃப்ட் ஹேண்ட் சைடு வந்து y of x, t இருக்கும். ரைட் ஹேண்ட் சைடு என்ன வரும்? C2 க்கு 0 போட்டா. சந்தோஷ் இருக்கியா இல்லையாப்பா?
சார் இருக்கிறேன் சார்.
ஆன்சர்
The question, sir.
Question. இவ்வளவு நேரம் நான் பேசுனது புரியலையாப்பா? C2 க்கு பதிலா 0 பா. C2 க்கு பதிலா 0 போட்டா என்னப்பா வரும்?
0 sir.
Very good. So y of x comma t is equal to 0. So அடுத்து third equation, fourth equation அப்ளை பண்ண முடியாது. So C2 is equal to 0 means, okay, the second equation will vanish. So we cannot apply other two conditions. That's why we are taking C2 is not is equal to 0. C2 is not is equal to 0. Okay. C2 is not is equal to 0. So therefore you have to take sin PL is equal to 0. For all the problem, this is the same. இந்த ஒரு 10-15 ஸ்டெப்பை எல்லா ப்ராப்ளத்துக்கும் இப்படி தான் எழுதணும். ஸோ சைன் பிஎல் இஸ் ஈக்குவல் டு 0. ஸோ சைன் என் பை வேல்யூ இஸ் 0. ஸோ சைன் பிஎல் இஸ் ஈக்குவல் டு சைன் என் பை. ஸோ பிஎல் இஸ் ஈக்குவல் டு என் பை. வாட் இஸ் பி இஸ் ஈக்குவல் டு என் பை பை எல். ஸோ பி இஸ் ஈக்குவல் டு என் பை பை எல். சப்ஸ்டிடியூட் this p value in equation number 2. What is the equation number 2? Here is the equation number 2. Here is the equation number 2. In this equation, you have to substitute for p is equal to n pi divided by l. So this equation can be written as y of x comma t is equal to C2 sin n pi x by L into C3 cos n pi at by L plus C4 sin n pi at divided by L. Am I right? If you apply P is equal to n pi divided by L. So here is y of x comma t is equal to C2 sin n pi x by L into C3 cos n by at by L plus C4 sin n by at by L. Take this equation number 3. Now we cannot apply the condition, boundary condition number 3 in equation number 3. Why? Because condition number 3 is dou y by dou t. Dou y by dou t is equal to 0. But equation number 3 is y of x comma t. How can we substitute? We cannot substitute. So that's why we are differentiating equation number 3 partially with respect to t. So dou y by dou t. C2 sin n pi x by L. You have to differentiate this equation number 3. Cos n pi at by L. Cos, if we are differentiating, minus sin n pi at by L. After that, n pi at by L you have to differentiate. If you are differentiating n by at by L with respect to t, n pi a by L. So minus C3 n by a by L into sin n by at by L plus C4 sin, if you are differentiating, cos. So cos n pi at by L. N by at by L you have to differentiate. If you are differentiating, you will get n by a by L. So take this equation number R. Now you can apply condition number 3 in equation number R. Condition number 3 in equation number R. Okay. So what is condition number 3? Dou y by dou t, x comma 0. For t you have to apply 0. For t you have to apply 0. So dou y by dou t, x comma 0 is equal to C2 sin n by x by L into minus C3 n by a by L sin 0, because the t is equal to 0, sin 0, plus C4 n by a by L into cos 0 is equal to 0. We have applied condition number 3 in equation number R. So dou y by dou t of x comma 0 is equal to C2 sin n by x by L into C4, because the sin 0 0, cos 0 1. So 1 into C4 n pi a by L. Sin 0 is 0. So that term, sin 0 term will vanish. So C4 n pi a by L is equal to 0. From this you can write C2 not equal to 0. Already I explained why we have taken C2 is not is equal to 0. Sin n pi x by L, that is also not equal to 0. N pi a by L, which is also not equal to 0. So we have to take only C4 is equal to 0. C4 is equal to 0. So substitute C4 is equal to 0 in equation number 3. C4 is equal to 0. So equation number 3 becomes y of x comma t is equal to C2 sin n by x by L, C3 cos n pi at by L. This is C2, C3 are the constants. So that's why which is equal to C2, C3 sin n by x by L, cos n by at by L. What is C2, C3? That can be taken as a Cn, sin n by x by L, cos n by at by L. In general, we have taken C2, C3 constant. That's why I have taken as C2, C3 is equal to Cn. So generally, we have written Cn. Therefore, this can be written as the most general solution is y of x comma t is equal to summation n equal to 1 to infinity Cn sin n by x by L cos n by at by L. Take this equation number 4. Now apply condition number 4 in equation number 4. What is condition number 4? Y of x comma 0 is equal to k into Lx minus x square. That is condition number 4. Y of x comma 0. For a t, you have to apply 0 in equation number 4. Very lengthy problem. T is equal to 0. Apply in equation number 4. So y of x comma 0 is equal to summation n equal to 1 to infinity Cn sin n by x by L cos n by at by L. For t, you have to apply 0. So cos 0 is equal to k into Lx minus x square. So cos 0, 1. 1 into Cn. Cn I have taken as Bn. Why? Because we have studied in the Fourier series as Bn. So that's why I have taken Bn. Bn as well as Cn both are equal. I am calling Cn is equal to Bn. Okay. So summation n equal to 1 to infinity Bn sin n by x by L is equal to k into Lx minus x square, where Bn is equal to Cn. This is half range sine series because summation is having only sine term. That's why this is called as sine series, half range sine series in the interval 0, L. Now you have to recall the Fourier series. Already